Welcome to a demonstration video for Purdue's Modsquad TA3 system for the Data-Driven Discovery program. The purpose of this demonstration video is to explore uncurated data sets and how they can be handled by the D3M system. Up until this point, the D3M system has processed on data sets that have been pre-created, C data sets that have been annotated for the types and the problem that was defined. But in the wild and in the real world, the data sets don't come pre-annotated and pre-selected. So the purpose of this demonstration is to show how real-world data sets can be processed, analyzed, and models trained and evaluated using the D3M system. We're going to go through the steps that are along the top here. We're curating some wild data, which means there's a new curation interface in Modsquad that allows data sets to be explored for where they're sitting. They're on an Amazon S3 bucket. They're in a NoSQL data set like Mongo. You can see the Mongo data sets. You can see something that's in the S3 bucket. We have an empty folder right here. I'm going to show you. We're going to fill it and then use D3M to analyze those data sets that are there. Also, if a user brings their own, there's an upload, you can bring your own data set, drop it here, and then use D3M to analyze it. So we really wanted to kind of look into the future and show how this could be used in new things outside of the SIG data sets that the program is used to working on. Okay, so for that example, we're going to take a geospatial example. We're going to make a point here that sometimes real-world, very large, very dense data sets need some custom exploration interfaces. So we're demonstrating that here through an application. We're taking a look at a year's worth of data from Instagram and taxi pickups in the New York area. The phase 2 augmentation has a seed data set for LaGuardia taxi pickups. So we're going to use Kennedy to show that this is uncurated data sets. Here's the black dots are the pickups of taxis during the course of this time. Let's select a period of 2 months. We're going to go from, let's just kind of go up here and pick from January to the end of February. All right, so we have 2 months worth of data set, and it's going to pull those over. So there looks like 35,000 taxi pickups in the Kennedy area during the course of those 2 months. And then we have a number of messages, 13,000 Instagram or Twitter messages that we have selected to view here. So this data set interface, we can explore some more, but it's out of the scope of what we're doing besides illustrating. We have messages and trip pickups. So this is the data sets that we can explore here. And I'm going to really, if we look at it more closely, like if we do the hourly sort of view, you can see some correlation between the number of taxi pickups, which are in blue, and the number of messages that are in red during the time. So we're going to suggest that, hey, if a data science user who's using this can say, this other red data set, these messages, kind of has the same pattern. So if I'm trying to predict the number of pickups, this might be a useful column to augment my data set for. So we're going to do export. We're going to save the actual trip values. This is the blue curve, the number of pickups there. And then we're going to also save this number of messages out there for analysis as well, because that might be a good augmentation column for us. So now we're going to go back to that curation interface and show you the data sets that we just created and captured. Let's check here. They should be right here in the geospatial thing. Okay, there's our trips and our messages. And these are not rolled up yet. I'm going to explore them. We get a little quick view, just table view to explore what it looks like. So these are not rolled up yet. They're just the exact date time that a pickup and a drop off happened. So this is one row per taxi trip. So we're going to roll that up here by doing ETL right in this interface. Modsquad allows a number of algorithms, primitives, to be directly run through the interface. This allows the user to do ETL that's necessary for what they understand about this data set. So if there's something semantically interesting or semantically critical, then the user can decide when and which primitives to run and how to do that. So we're assigning the input and output. So we're going to say trips by hour here, and we're running this little primitive to do an hourly roll-up of those individual trips into hourly category, hourly counts. Again, these primitives we've created, they're just wrapped Python routines. We're running them in a Docker container that's managed by this interface. But these could be the actual D3M primitives that are run here through the interface, either directly through TA3 or by calling TA2 and invoking. So we wanted to point out that this is something that's capable here with Modsquad now. So I'm going to roll up the messages while we're at it here. And then we can use them to, we'll make the, while we're at this, okay. So let's do that. Now we'll take a look at the trips that are rolled up, and we'll go do an analysis for it. Okay, let's take a look at what we did here. Geospatial, trips by hour. Now we have, instead of the individual trips, now you can see we have number of pickups set up by hours. You can see hour 1, 2, 3, 4. So this is rolled up by hour. Let's go ahead and do analysis on the trips by hour just as they are, and then we can come back and annotate this data set. We won't need the geospatial interface at this point here, but I just wanted to. So now we're going to go on to, here's the view of what data sets are in that curation space. And you'll see here's our messages by hour, here's our trips by hour. At this point, we could also take this data set and invoke data mart. We haven't done that yet in this video, so we're going to go ahead and just select the trips by hour here. And we get an opportunity to explore those trips. Here is what it looks like. We can explore each individual data set value or attribute. We get a histogram of those attributes where they are. You get all values plot to show exactly for each hour. Some of the hours are 0, some of the hours are over 65. This is a simple way to explore the data set. We get a little bit of online help. So we're still being sensitive to those who are not familiar with data sets, design or data science. Here we can pick what our target variable is going to be. And then so we're picking the number of pickups. And you can take a quick look at how that variable relates to the other variables in the data set as a way to explore what's happening. And now we're going to do the training on this. And you saw I picked the target variable as the number of pickups. Since this is a raw data set, Purdue Modsquad here creates the data set description, creates the problem description, and copies that data set over into the shared space between the TA2 and TA3, along with the specs that are generated on demand. So we can pick whichever target variable that we want to explore, and then run that way. So this allows really unfettered hypothesis creation by an individual who's exploring this data set. We can do the number of trips here. We could explore other variables that are in this data set, and that's a value of being able to empower the user to do some smart ETL steps and then exploration of the different target data sets without having to change annotations that are created on the data set. All right, so we're fetching our results here from the first training. All right, so here is we are using, this is a regression problem since it was a numerical variable. So we're returning an R² value here. So we got a which is between 0 and 1. So we got 66%. Let's record that over here on our pickups. For alone, we had 66.8%. Okay, and now we'll go back and do the annotation of the data set. Go back here to the user interface. Okay, so let's come here and remember we had both the trips and the messages by hour, but we don't have them combined yet. So let's do append columns because both of those data sets are set up by hour. So let's pick those. We can do our geospatial. Let's pick the trips by hour as our first data set, and the messages by hour as the second data set. And then our output is going to be augmented trips. All right. Execute that task. There is a task interface to allow you to explore what tasks have been done, look at the history, where they were spent, how long they were running, and everything. Okay, this one is finished now, and so we have the augmented trips, and if we look at a quick exploration, we'll see that there's now a number of pickups column and also a number of messages column. To exploring the model fit against the augmented trips. So we'll go forward here. You'll see that we have both the number of pickups and the number of messages now in this data set. All right, we're going to pick the target variable here, number of pickups, and then we'll go to train. Now we're fetching the results, and let's see here the best fit. Again, this is R squared. The best fit pipeline is now 68.5, right? Let's compare to what we had before. It was unaugmented. Unaugmented was 68.8. Augmented was 66.8. Augmented was 68.5. So the augmentation did improve the results of fitting. Oops. Let me show you this one. Here we're going to select it and explore what model diagnostics visualizations we have currently in Modsquad. This is an area that we're now pivoting to work on more with our team. Here we're plotting the residuals against the actual number of pickups. So this is the target variable, the number of pickups, and this is the error between the predicted value and the actual value. What we ideally want is to have the data points centered all around this residuals equals 0. So that would mean that the model prediction was very close to the actual for all values of the actual that it took in the data set. You'll notice here a slight upward trend away from 0. So this model predicts very well for small numbers of pickups, and it's not as accurate for the larger number of pickups. We also look at the predicted values versus the original data set, because someone who understands this data set semantically will also be looking for relationships that don't make sense between the predicted values and the other variables in the data set. All right, so I just wanted to summarize what we've shown you here is that Modsquad can run on uncurated data sets. We took a real-world problem, dynamically used a custom interface to subset data out into data sets. We did some ETL curation that was under control of the user. That's a great place for the D3M primitives to be made available to the educated users as needed. And we that also could just be, again, could run the TA2 pipelines. So we did that, and we compared and we ran models against the original and augmented data set and saw that the augmented did indeed preserve the results here. So this is a demonstration that we're excited to show you because there's now this full beginning to end capability in Purdue Modsquad. Thank you for your attention.